in RELX. It's one of the largest divisions of RELX, and the topic is quite interesting because they are not unlike what we heard from Raj at the beginning of the day in the morning. They are also leveraging AWS, but in this case is to do a scalable performance research analysis on AWS using HPCC. And with great pleasure, I welcome Sreekanth to present what they have done in Elsevier, which is our sister company. Welcome, Sreekanth.
Hello, everyone. I'm Sreekanth Mopuru. I'm Principal Software Engineer with Elsevier. I have been working in HPCC area over 7 years, mainly developing analytical products for Elsevier. For past 3 years, I worked on a product called SciVal, for which I worked on migration of our HPCC clusters to AWS Cloud Platform. Much of my talk today will be focused on that. However, I will give you a quick introduction to our product, SciVal, just to give you an idea on the amount of computations we do and how we use HPCC. SciVal is a research performance analyzer, mainly used by research administrators, department heads, and researchers themselves to evaluate research performance of institutions, countries, group of institutions, group of countries, departments, many other entities that we support in SciVal. It is based on Scopus abstracts and citation database. This database contains over 60 million scientific articles from 20,000 peer-reviewed journals, and we also have 550 million citations that we process. In addition to Scopus data, we also use some other data sources like usage data. This is gathered by tracking the abstract view events from our other product from Elsevier called Scopus or Scopus.com. We also use patent data from LexisNexis as well. Using all these data sources, we generate many metrics, metrics to measure amount of output, metrics to measure quality of output, and also metrics to measure the extent of collaboration between institutions and countries as well. SciVal is modular, and we have 4 modules. And here I have the first module overview selected. And in this module, you can select a single entity from the left-hand panel and see all the associated metrics. Here I have Stanford University selected, and you can see the number of publications, citations, and number of authors for Stanford. Additionally, we compute a metric called field-weighted citation impact, which is a normalized citation value with the world benchmark at 1. Stanford has 2.49, which is good. And down below, you can see the distribution of Stanford papers across various disciplines. Here is another screenshot from overview module showing some other interesting metrics. Top citation percentiles, this is the percentage of Stanford papers that are in top 10% most cited publications worldwide. And also top journal percentiles, this is the percentage of Stanford papers that are published in top journals. And addition, there are 2 more metrics in this screenshot: international collaboration, which measures the extent of collaboration with the other countries, and academic corporate collaboration, which measures the collaboration with the other corporate institutions from Stanford. In addition, in the overview, we compute several top end lists as well, like top countries, top institutions, top journals. And here I have top authors listed. And these are the top authors for Stanford in the field of in the computer science field, and authors are ranked according to the number of publications. This is a screenshot from second module we have, benchmarking. In this module, you can select over 100 entities from the left-hand panel that I showed earlier and directly compare their metrics. Here I have a scholarly output or publication output selected, and I also selected some of the top institutions in the world in the field of computer science. And for year 2015, you can see Carnegie Mellon is at the top, followed by MIT and Georgia Institute of Technology. Here is another screenshot from SciVal showing the, here you can select an institution or country and see its collaboration with various institutions across the world. And here I have selected Stanford, and you can see the extent of collaboration with the institutions across various regions in the world. And you can zoom into any level, and here I have zoomed into country level, and you can see the all the institutions in Netherlands that are collaborating with Stanford. And the number inside the bubble is the number of collaborating papers, and you can click on that and get more detailed view of collaboration metrics. Here is the fourth module we have called Trends. And here in this module, you can analyze the research area trends or analyze the research areas. And I created this research area called Machine Learning and Data Science by searching on the words, those words. And I got 693 papers for the year range 2011 to 2015. And you can see various metrics listed for those 693 papers. In addition, you can see the contribution from institutions, countries, and authors into this research area by going into the other tabs listed there. We also compute top key phrases for this research area, and they are shown in the word cloud form here. Like I talked about, we have several entities that we support in SciVal. For any entity which has more than 5,000 documents, we compute the metrics for those entities in Tor, pre-compute those, and we call them pre-computed entities. Otherwise, they are dynamic entities, and metrics for these are directly computed on the fly on the Roxy. So we have over 600,000 pre-computed entities, and with 21 years that we support from 1996 to current year, and over 1,000 subject areas that we support, you can see the amount of computation and storage power required to pre-compute 30 metrics. And also, in addition, we compute several top-end lists as well, which requires even more computation power and storage capacity. Here is a high-level architecture diagram for SciVal, and we have a syndication system which generates a full weekly snapshot and stores it in AWS S3 bucket. And we have a SciVal controller module which runs sequence of steps to complete a weekly job that we usually run on the weekends. And first it runs a spray job to move the data to Tor, and runs the index job to compute metrics for all the pre-computed entities. And it runs the data deployment job to move the data to Roxy. We have 2 Roxys, so data deployment is done one at a time so that there is no downtime to the end user. In addition to weekly job, we also run a delta job that we run on weekdays usually. And these delta jobs, we process any newly created user entities since last weekly job was run or last delta job was run. Since we launched SciVal in 2013, there has been constant need to grow our capacity, both computation and storage, mainly for the reasons listed there. Growth in the user entities itself, because as our customer base has increased, and the underlying article data as well as the usage data growth. And also we are adding new features and metrics all the time, and new data sources as well. So because of this constant growing needs, capacity needs, we were looking for options to migrate our clusters out of traditional data center platform to a more cloud-based platform. And AWS or Amazon Cloud Platform was obvious choice because HPCC was supported on that. So last year, April, we started on the AWS prototyping effort, and Tim Humphrey from LexisNexis Risk Solutions provided us with installation and configuration scripts for HPCC, and we started out with those and made some enhancements, and we used small AWS instances for prototyping, and we were able to successfully install HPCC, Tor, as well as Roxy on these instances. And we also ran test jobs and test queries both on Roxy and Tor to verify everything is good. Then we started working with our full production load and experimented with several AWS instances, mainly to determine the best possible configuration, both in terms of cost as well as performance. So we used very large instances that AWS provides. These are called 8 extra large instances, mainly because they support very high network bandwidth or 10 gig bandwidth. And we also put them in a placement group, mainly because it guarantees the minimum network latency that is required for Tor. So for Tor master, we used an instance called C3 8 extra large. And in addition to running the master process there, we run all the admin middleware processes as well. And we also used it as a landing zone as well because it has enough storage capacity for us. For Tor slave, we used an instance called D28 extra large. As you can see, it's a very large instance with 36 CPU and 256 gig memory. So because of this, to fully utilize this node, we are running Tor in multi-Tor mode, and we are running 16 slaves per each instance. For Roxy, we can run only one process per instance. So we used the smallest EC2 instance that still can support 1 gig high bandwidth required for Roxy. So for Roxy, we used I2 2 extra large, and for master, we use C3 4 extra large because we can still run all the admin process there. And storage capacity is small, because that's okay because we don't need a landing zone here. So with this configuration, we ran several load tests and verified the performance was good. And next, we started building out our full-scale Tor and Roxy environments. Before I show our AWS deployment architecture, I would like to go through some of the terms in AWS just for the benefit of those who are not familiar with AWS. Virtual private cloud, it is a virtual network that is dedicated to AWS account and completely isolated from all other networks within AWS. And you can have private or public subnets within MVPC. A typical use case is to put all the infrastructure components in a private subnet and put only the components that you want to expose to internet on the public subnet. Elastic load balancer, this can be used like a typical load balancer. You can put several EC2 instances, and it distributes traffic evenly across those EC2 instances. Another use case is to use like a gateway or internet-facing entry point into your VPC in a multi-tier architecture. Next, auto-scaling group. You can put several EC2 instances in an auto-scaling group, and auto-scaling group will manage those instances. And if there is a problem with any instance and it's not responding, auto-scaling group will automatically terminate that instance and brings a new instance in its place. And other obvious use case is to scale up and down number of EC2 instances you have depending on your traffic need. Next, security group. It acts like a virtual firewall that control access to one or more EC2 instances or even the ELB itself. You can specify security groups in terms of IP ranges, protocols, and ports. Here is our AWS Tor deployment architecture. Like I mentioned earlier, we are using C3 8 extra large for Tor master and D2 8 extra large for slaves. And in current production right now, we are using 5 D2 nodes because we are running 16 slaves per each instance. This is equivalent to a 80 node cluster. And we put all the instances in an auto-scaling group and set the minimum number of instances to maximum, same as maximum, so that auto-scaling groups maintains a stable number of instances in the HPCC clusters. And both the auto-scaling groups are put within a private subnet, and we have a ELB called Tor admin ELB that is inside public subnet that provides access to the HPCC clusters. We also associate a security groups for both ELB as well as instances to restrict access to the HPCC cluster. And you can also see that all the AWS components here are put within a VPC. Here is the Roxy deployment architecture, which is very similar to Tor, except that we have 2 Roxy clusters, one in each availability zone. This is mainly for high availability. And just like Tor, we have a admin ELB. There are 2 of them providing access to their respective clusters. And we also have we have 2 more ELBs. one Roxy external web service CLB, and we put both the Roxy admins inside the CLB. In this case, it acts like a true load balancer and distributes traffic across the two Roxy clusters. And other we have down below, you can see Roxy internal cluster ELB. This is used to actually load balance the actual Roxy nodes within the Roxy cluster. So the Roxy ESP is actually configured to send requests to this internal cluster ELB. With this configuration, when we are running over a period of time, we have found one issue because ELB's internal IP can change. AWS can change without notice. So in that case, Roxy ESP was losing track of the ELB. To address this issue, we put a proxy in between, and we used a HA proxy for that. So the flow of request is first the request comes to the external web service ELB, and it is sent to one of the Roxy clusters, and the Roxy ESP sends it to the HA proxy, and which in turn sends to the internal cluster ELB, and that sends request to one of the Roxy nodes. Next, I'll be talking about recoverability and redundancy. Like I mentioned earlier, we put all the EC2 instances in an auto-scaling group, and it manages those instances and terminates them and brings a new instance in its place when there is an issue. So, however, the new instance comes back with a different IP, and hence HPCC configuration was not recognizing it and was not getting absorbed back into the cluster. So, to address this, we used a AWS resource called Elastic Network Interfaces, ENI. Using ENI, you can create a fixed IPs, and you can bind these fixed IPs to the EC2 instances. So we resolve this issue by using the ENIs. Next, the data recovery. Recovering from Tor slave instance loss, we just simply run a command called start backup node, which will copy the data from the adjacent instance as you specified in the HPC configuration. For Tor master, we turned on DALI replication, and all the DALI metadata is stored in another replication instance. And in case of Tor master loss, we recover data from that place and restart the cluster. So for Roxy, we turned on cyclic redundancy. And in the case of Roxy, it's much simpler because data is automatically recovered. When the new instance comes back, it automatically starts copying data from the adjacent instance. Another good thing about Roxy is it can function even with the loss of single node. And so in this case, there won't be any downtime to the user. Next, DR scenarios. Both for Tor and Roxy, a DR scenario would be losing two adjacent instances as you specified in HPCC configuration, or lose the entire HPCC cluster due to some reason. So to manage this for Tor, we take periodic backups to AWS S3, and for Roxy, this is very unlikely to happen because we have two Roxys in separate availability zone. But we also, just in case, we take backup of Roxy index data in Tor, as well as we also maintain a copy in AWS S3 as well. Next, monitoring the HPCC clusters. We used a couple of tools for this. First, Nagios, and this is an open source monitoring tool which help monitor all the system resources like CPU load and disk usage. And in addition, HPCC provides a plugin to monitor all the processes like Tor, Roxy, and all the middleware processes like DALI, DFU. So Nagios sends out alerts when there are issues with any of the system resources or any of the HPCC processes. So, and we also configured Nagios to send alerts to an online chat tool that we use called Slack. And this is really useful because it's easy to monitor the clusters during the off-work hours. Here is a screenshot from Nagios. You can see various checks that are being performed, like check disks and checks for all the HPCC processes, and also check load, and many other checks are listed there. Next, Ganglia. It is also an open source monitoring tool which helps monitor the clusters. And it is complementary to Nagios because in Ganglia, we can maintain the historical data. So just like Nagios, you can monitor all the system resources, but in addition, you can, in case of any issues, you can easily go debug and investigate issues that happened sometime in the past. In addition, HPCC provides plugins for Roxy metrics, so it is possible to view historical data on the Roxy metrics as well. So some of the Roxy metrics are listed there. Here is a screenshot from Ganglia showing the CPU load, and all the activity you see on Sunday and early part of Monday is due to the weekly job we ran, and other spikes are due to the Delta jobs that we run. Here is another screenshot from Ganglia, and here Roxy metric query count is shown, and it is a cumulative graph, and you can see for a period of a week and also for a period of a month. I have talked about several AWS resources that we use, like VPCs, ELBs, and EC2s, and you can automate creation of AWS resources using CloudFormation templates. And here is a screenshot from our Thor CloudFormation template, and you can see several parameters there. Main things to note are the suffix and environment, the first two variables that forms the name of our cluster. In this case, it will be cert Thor1, and you can also see the instance types, and also the number of slave instances, which is 5, and number of slaves per each instance, that is 16. Some of the enhancements we plan to work on. Right now, the S3 backup times is taking too long, like it's taking 7 hours, and we are looking for ways to cut down this time using Delta copies and other mechanisms, and also looking for tools to easily expand the clusters. Recently, we migrated, expanded our clusters, so we had to write specific scripts to copy data from old cluster to new clusters, and we are looking for tools in this area, and as well as easily expand the clusters without having to create new clusters. And also, we are planning to upgrade our HPCC version to address some of the issues that we encountered earlier during the migration. So in summary, HPCC on AWS has worked great for us, and it is very easy to install and configure HPCC on AWS platform. Using the CloudFormation template, we can easily bring up Thor or Roxy cluster within 30 minutes, and it has been very robust and requires very little maintenance. And even though I talked about DR scenario earlier, we have never faced one since we went live last November. And even the instance loss happens very rarely. It happened once for Thor and maybe a couple of times for Roxy, over a period of nearly 1 year. And just being in the cloud, it is easy to scale up and down. And we are using AWS resources like VPC and security groups to provide layer of security over HPCC clusters. And finally, Amazon comes up with new instance types all the time, and it is getting more and more cost effective to run HPCC on AWS. And finally, here are some of the people I would like to thank for their contributions and also timely responses in resolving the issues that we faced during migration. So big thank you to all of them. So that concludes.
There is a question?
Any questions?
Yeah, we can take one question. Any questions there?
Yeah, go ahead. No, we kind of bring up the cluster, and because we build on the data that we build initially on the weekly job that I shown, so we keep up the cluster all the time. So, okay.
Thank you very much. Thank you. That was a great talk. I did like it. By the way, for those that are in the community and the ones watching on us in video, the CloudFormation templates, those are available, are of course open, so feel free to check them out. If you need to deploy an HPC cluster using AWS or any other public cloud services, is a very good way to get started. And if you are using AWS, those CloudFormation templates will really help you. Now, for our next talk, we have another person in the RELX family, is an organization that is part of RBI, and they do flight analytics. And I was trying to avoid to disclose it before the time, but by now you will figure out who they are. So this is a Flight Global, is again part of RBI, and they have done quite a bit of work on HPCC. Michael Targett will talk about some of these, of the things that they have been doing until now, and what the future prepares for them on HPCC. So please welcome Michael Targett on the next talk of the day.
Can everyone hear me? Yeah? Good. And thanks for picking a cool song, Trish. That's a good one. Although somewhat depressing to learn that that's now 18 years old, that song. Right, so thanks for the intro. What I'm going to be talking about is a project we've been working on at Flight Global to develop a new aviation analytics capability, and how we've been working with HPCC to help us do that. So just one caveat really before I get going, which is we've seen some really good deep dive technical presentations. This one's a little bit more commercial focused, but I do have some of my colleagues here have been working on that. So if you want a deep dive into how we've been working from a technical perspective, come and find us. So cracking on then, I've got a couple of slides just to set the tone, a bit of context, so we can understand a bit more why the new capability is important to us and important to the industry. So this is the aviation information marketplace. The blobs represent the size of opportunity for us in those spaces, and what we've got here is globally, we reckon that's about a $3 trillion industry going on at the moment. Flight Global's traditionally been working on the left-hand side of that picture in aerospace and air finance. That's the buying and selling of aircraft. So we've got really strong market-leading propositions there. But what we've been pushing on for the last 4 or 5 years really is into that big red blob, into the air travel industry. And there's some really exciting opportunities in there. So, and the other thing that we need to understand about the industry is from a data perspective, these are the data sets, access to these data sets that give us the right to win if we're doing a good job. So there's 6 of them. There's the fleet information. That's really information on a tail number by tail number basis. You've got the schedule. That's what the airlines say they're going to fly. Then you've got flight tracking. That's the positional and status information that various companies track. Fares and traffic. That's around demand and what's going through the booking systems and the reservation systems. You've got the costs of operating those flights. And this new thing, the new thing, it's not really a new thing anymore, the direct sales, so the web fares, particularly relevant when it comes to low-cost carriers. So accessing that data is really important. Combining that data is where we really see some unique value and some big opportunities. Okay, so this is the problem, and I'll explain a little bit about the problem as we go through these slides. That we've been working to address, really. So I'm talking about analysing aircraft utilisation by route, and that's a bit of a weird description, but what I mean by that is when you're analysing the industry and what's flying where or what's planned to fly where, you're really trying to understand what aircraft is flying on that route, and that's not a very easy thing to do at the moment, or hasn't been in the past. Hopefully, we're getting there. So the kind of, next slide, it goes a bit further into that problem. But these are the kinds of user cases and people that's really important to. And there's lots and lots of different use cases, but I picked a few out just to bring a bit of relief into the use case, into the case study. So there's 3 things really just to pick out. So capacity, that's about literally how many seats are on an available route, and you add it up and do your plans from there. I think people like network planners, that's really important to understand what's going on and how to analyze which routes to optimize, which routes to fly, or which routes not to fly. Then you've got the equipment itself, so the actual aircraft, the actual piece of tin that's flying around. And that's important for people like fleet planners, for example, where they've got a mixed fleet and they're saying, well, which aircraft should I put on that route? You know, what does it make sense to operate there? And then in terms of product offering, and this is quite exciting around here, so we're talking about moving out into the traveller services, really. So you guys are probably all really curious when you're booking a long-haul flight, say, well, what kind of seat can I expect to sit in? What kind of in-flight entertainment system am I likely to be staring at for the next 10 hours? So those are kinds of things that you know, if you're able to map aircraft to route, then you can start to offer that kind of solution. So the problem currently about trying to do that is that any analysis, even if you're going historically or you're trying to project out going forward and anticipate what's going on, is based on the schedule plus any assumptions or estimates that you're including. So the schedule is, unfortunately, what the airlines say they're going to fly. Now, we all know that sometimes that doesn't happen. There can be events that make sure that make that, you know, not a viable thing, or sometimes airlines themselves are deliberately vague. They don't really know what they're going to allocate, so they say, yeah, I'll probably operate a 747-400, but I'm not sure, and they might change it. So that has some challenges, really, and you end up with a flawed data set. That's not to say that the schedule isn't good. It's only as good as what the airlines say it's going to be, plus any of the estimations that you choose to put in. But our hypothesis is that the more accurate we can make that information based on observed activity, then that will prove the differentiator out there in the marketplace. And we'll be able to capitalize on some of those opportunities. Okay, I've got two case studies that I'll rattle through here. And these are the ones that are quite cool because they begin to sort of explain why that's a real problem for network planners or fleet planners, for example. Okay, so this first one is we ran some data on a bunch of carriers who were flying between the US and China. And what we've got here is the vertical axis is showing number of seats added up by those airlines flying those routes. And you've got about 6 months worth of data going across. So to explain what we're looking at, really, we've got the light blue line is what the schedule is showing. That's if you were planning on you're forming some calculations based on what's included in the schedule, you'd be operating off that light blue line. And then the purple line is what actually flew. So the thing to pick out really is the bigger the gap, the bigger the miscalculation that you're working off. And then, so from looking at this graph, if the lines map, then presumably the airline is being truthful. It's saying, I'm planning on flying this, and I actually am flying this. But what's quite useful is if we drill into August, for example, we can see that's not necessarily the case. So here we've got each line is a flight. The bigger the line, the bigger the difference between the actual and the scheduled. So you've got the light blue is when the schedule overstates it, and purple is when the schedule understates it. So you begin to see with Air China there, there's all kinds of stuff going on. Don't know what's going on. And then the other airlines, you've got a slightly less variation, but the ones that we thought potentially were telling the truth, or not telling the truth, but were stating what was actually going on, is not necessarily the case. So you've got China Eastern and Delta that are just doing regular, consistent small changes, but they're potentially cancelling each other out. It's only China Southern, really, in this case, that is submitting the information in its schedule that is actually going to happen, or has actually been happening. So if you're a network planner, or someone who capacity information is really valuable, this particular example is really stark, actually. So just looking at that Air China line, this is just the August data, and the schedule overestimation is 18,500 seats for 1 month. Now, that's huge, actually. So that's a 17% overestimation. That equates to, effectively, 2 full Boeing 777-200s flying every day. So, you know, that's a big assumption that you're making on that particular example. So that's capacity. What about changes to schedule? So we all know that flights can be subjected to changes. We can have meteorological or political or sporting events which mean that airlines react to what's going on and they go away from the plan. And this one was quite a cool one to dive into. So if you remember back in, what was it, 15th of July earlier in the year, there was a political coup attempted in Turkey. So we went back and had a look at what the schedule was saying and what the effect of that coup was on the schedule. So what we've got here, a number of flights in the vertical axis and the days of the schedule going out from the 15th being the dotted line. And you can see, so those are the flights sort of drifting around there, up and down, dipping on the weekends. And so we reran that to say, okay, well, let's have a look at how the schedule reacted the further away from the coup day we got. So what you've got here are airlines within the first couple of days, just trying to get their heads around what's going on out there. And then they begin to react. They begin to drop capacity and the number of flights in and around Turkey. And you end up, you know, with 4 weeks out with a new adjusted schedule. So that's cool, that's pretty interesting. But it doesn't actually show us what happened. It just shows us the adjusted schedule versus the old schedule. So when you start to map that out, you can see that what actually happened is quite dramatic. So in the days following the coup, we've got over half the number of flights are cancelled, half the amount of capacity gone. And it really takes another 10 days or so for that, for what's actually happening in the sky to come back and match the new adjusted schedule. So that's just a very specific but interesting case study there. And we can rebase that to get a sense of how it's coming down. And then the final one really to sort of drill in and understand filtering down by domestic traffic versus international traffic, if that was the kind of thing that you were interested in looking at. Okay, so you might be wondering why I'm 20 slides in and this guy hasn't even mentioned HPCC yet at the HPCC summit. I am getting there. The good thing is actually those last 2 case studies came out of our project, and that's what we were using HPCC to help us. So we were able to run that data because of the work we were doing. So we call it fleet flight matching, and this is about effectively matching what's flight. Well, I'll go back to my jigsaw first, and then we'll go from there. So I'm talking about these top data sets out of the 6 core ones now. So Flight Global traditionally has had the world's leading fleet database of 350,000 aircraft, of which we're talking, in this case, about the 29,000 ones that are commercial aircraft flying around. And we acquired a business called Innovator, which is just up the road from here in Georgia, about 4 years ago, 2014. And they were one of the 2 producers out there of the world's global schedule. So that gave us the fleet and the schedule. But we needed the flight tracking information to be able to place an individual aircraft on a scheduled route. And that's what we've done. We made a recent acquisition with a company you might have heard of called FlightStats, based up in Portland. And they're the leading provider of flight status information, taking a lot of this observed aircraft movements and aggregating it into flight status records. So that gave us the key, really, to start building our fleet flight matching model and doing all kinds of cool stuff. So, so there's a bit of I won't bother talking through this one too much, but it's just to say it's improving our historical analysis and allowing us to build out projections from there. And we see this as a critical player in making and supporting strategic decisions within the air travel industry, and also lots of operational applications as well. So here are some of the sort of broad level applications, and it kind of splits into a 2x2 grid. So you've got aircraft attributes. So that's stuff that is on an aircraft or associated with an aircraft, right? So that might be its engines, that might be the number of seats on board, it might be the amount of hours and cycles that aircraft has done, which is important data. Might be who owns it, or how much it costs, or how much it's valued at. And you've also got aircraft activity. So this is observed aircraft behavior. You know, how long did it spend on the ground? You know, where did it fly between? What were the conditions at the time? That kind of thing. And fleet flight matching allows us to build up a true historical picture of what's going on, both with the application of the aircraft attributes and how it's being used. And from that, we can start to project out and say, okay, well, from all the data that we've built up in the past, what's the most likely thing to happen in the future against the schedule? And you can see some of the case studies there. So we put a project. If I go back, so we put a project together back at around May time to say, okay, we understand the opportunity here, we understand the problem space, how are we going to solve it, and what choices we're going to make about the project process, including technology choice. So the technology choice was an important one for us right from the beginning. We could see that we had a need to, we were going to have to iterate very quickly and many times on this. There was going to be a lot of trying and testing and refining how we built and construct that data matching and how we filled in the gaps if we didn't have that information, what assumptions we made. So we needed something that we could prototype rapidly on and iterate from a research and development perspective. We also knew that the data, although it wasn't huge to start with, was going to scale very quickly. We have about 100,000 flight records a day, and we want that data every day. So that's going to build up very quickly. So we needed something that could scale to match the data set. And we also have a lot of subject matter expertise at Flight Global. Doesn't potentially, perhaps doesn't come from a very technical background, but these guys know the industry really well. They know the customers really well. So we needed something that offered an environment through which we could showcase some of the findings and explore them, potentially in a visualized way. So we wanted to actually, it's a good point, so we wanted to blend a team of different skills together so that we can move forward on fleet flight matching. Actually, the guys up the road in Alpharetta were kind enough to sort of pitch in. They saw the opportunity as well, so we all went and up sticks to Alpharetta, and it was a combined team full of HPCC people and some data visualization people, some subject matter experts, some commercial people, all getting together and focusing on cracking this solution and cracking this problem. There were a lot of, I've gone through a few of them actually, a lot of different ways and applications that we could use this data. So we needed a methodology through which to focus on the most valuable return. So we've been using the lean value methodology to really sort of anchor, focus in on customer bets that we see really high value from. So we're able to use that lean value process to sort of have a coordinated and organised approach to which things we were going to try and focus on. I've got a slide on that in a sec. And we wanted to think about how this project was going to play out. How do we test and learn whilst at the same time building the infrastructure and building the capability to get this into the marketplace and start to make some money out of it. So from a lean value tree perspective, so lean methodology is all about visualising what bets you're going to go after, what customer bets you're going to go after around a common sector or common goal. So these are all the bets here. The dark purple boxes, just to explain a little bit, are promises of value to our customers. They're different ones. Each one represents a different promise of value, potentially to a different customer. And this whole tree is all activity around where fleet flight matching is going to be. So the big black box at the top talks about the overarching goal, and all the way down to customer outputs at the bottom. And the thing to pick out really is these light blue boxes, which are where the HPCC work was coming in. So these represent particular types of data activity that were going on. Each one of them is a milestone or an output, and where they run across sets of bets, that's where they have common features to them. So the top one, for example, which runs across everything, is produce a completely matched file of fleet and flight. And these were the things that we centered on through our POCs and our R&D basis. So important to the process here was analysing, visualising and communicating this out. We were doing some brand new stuff. We wanted to check with customers that it was a value for them. So when we were doing the POC, this was our approach. So we're just spraying the different daily versions of the 3 core data sets. The one at the bottom is the SIM is the industry standard for schedule. It's the format. We're spraying it into our cluster, applying some code to build basically a super file of everything, and then applying code again to produce those output files we're talking about. And then doing whatever we were doing with it. So we were using the data science portal in those POCs to visualize and explore the information and just to validate that it was worth going down that route, and we were likely to find some interesting stuff. Actually, here's some screen grabs from right back for those early days in the POC from using the data science portal. Just to explain a bit what this is showing. So this is one of those data views is accumulated time on ground for aircraft. So the bigger the line here, each one of those is on a specific aircraft. The bigger the line, the more time spent at that airport. An airport is a row in this case. So what we were trying to do is saying, actually, even with this simplistic view, could we work out where individual aircraft were based? This is information that's quite interesting for some people. So we've actually refined this, so we've got more features that go into this now and give us more, give us a more rich score. But in this case, all we were saying is that, yeah, we actually, based on what we can see here in the DSP, we think we know where these aircraft are based, these British Airways aircraft. And this was another output that we were working on through the project. So this is about hours and cycles, really important to certain industry people, certain industry roles. This is about understanding exactly how much time the aircraft is spent in the air, how many times it's taken off and landed. It's a highly regulated industry. All the you'll be pleased to know, and all the aircraft have maintenance cycles they must go through. So this is information that people are really interested in, and we were trying to work out whether we could calculate this information from observed behaviour. We get some of the information for the world's fleet directly from OEMs like Airbus and Boeing. So we're able to train our data and say, you know, how close do we get to the stuff that we actually get the records on? And you can see in the early stages, we're getting quite a lot of scatter here. So we had to iterate, adjust our assumptions, and see where we got to. And actually, as we go through those iterations, we start to see some really positive effects and results. So the bottom two are improvements on Airbus information. So you can see we're really close to the line on some of that, and getting to a point where a high degree of confidence, and we can start thinking about how we expose that information into the marketplace. The one at the top is Boeing. So we're still getting quite a lot of noise around Boeing. And what's interesting there is we think, well, what's the difference between Boeing and Airbus? The model's the same thing. We think we might have stumbled across, so what happens is the airline submits the figures to the OEM, and the OEM releases those figures, and we think we might have found an inconsistency in that process. So it might be another opportunity in terms of offering benchmarking services for the OEMs themselves. So just a few more slides then, really, to further explain about customer discovery, because it's such an important part of this process. So we're doing this new data combination. It's really interesting, but we've got to prove the value to the customers out there. They're obviously using data already to do their analysis. The effort for us is to say, hey, there's this new norm now, and it's much more different, and it's much better, much more accurate. So we built some visualizations that helped to demonstrate this. This is a true capacity demonstrator. So you can pick a route between an origin and destination, and what it'll do is it'll show you in a series of graphs the difference between what was scheduled and what actually happened. It will show you the difference, whether that's a different aircraft or just a larger number of seats. And we shoved in a few different sources of information there as well, so it depends on what the customer's currently using, just to really emphasize that. And then there's another tab which allows you to break that down by class of travel, so first, business, premium, economy, etc., which is highly valuable for people. So splitting down by class there. And then I think this is my last example. So this is quite a good one though. I like this one because it's a visualization of aircraft time on ground. So it's quite simple, but works quite well. So when the line, you've got March and April months of activity for this particular British Airways aircraft. When the line is at the bottom, it's on the ground. When it's up at the top, it's in the air. So you see it doing regular flights, and then we've got these extended periods on the ground, and that was quite interesting for us. And we were saying, well, what's going on there? Ordinarily, that would look like a maintenance event, but 3 maintenance events in quick succession, that doesn't feel right. It turns out that this aircraft is actually being used as a spare aircraft, so it rotates around and fills in when it needs to, and when it doesn't, it sits on the ground waiting. So it's quite interesting. And I like this one also because it begins to talk about why we need scale, why we need HPCC to help us. So if we were looking to apply this visualization or this level of information against every one of the aircraft in our database, we're talking 28,000 in-service aircraft, and we want to run that across every day's worth of flight records. And so far, we've got 180 days worth of data. We're already up at a big number, so we already know that the scale is really critical for us here. So the next steps really is about getting this into production. I've got a high-level design diagram here, which I'm not going to go into, but you can see the R&D environment there we were working on. We've got our production environment that we're going to set up on. And just one thing to call out is the data movement, data ingress is a critical component for us. And then the final slide really is just to sort of say, going forward, scale, as I said, is hugely important for us. We've been collecting aviation data on the fleet for the last 50 years, and our fleet flight matching database is already bigger than that. And we've got some cool stuff. We're using some cool stuff like the roll-up and the dedupe stuff to solve some of the challenges around multiple flight records of the same flight. So the last thing to say really is that we see HPCC and fleet flight matching supporting a sort of a new foundational data set for Flight Global and a chance to really exploit some of those opportunities in the marketplace. Thank you.
Thank you very much, Mike. So we don't have, unfortunately, time for questions. This was a great presentation. I love to see how they've been transforming their division with this type of analytics, particularly with the volume of data they are getting, 1.5 terabytes, and this only keeps growing. And the more analytics they do, the more data they need to ingest, and they are continuously looking for new data sets, so that's great. But now we have another presentation, and this one is also very interesting. It is around another division of RBI that does precision agriculture and some of the analytical services for farms, but also have a novel enterprise bus system that we have integrated in HPCC, and it's part of our stack, our strike stack. And this is the I for Strack, interlock. So I help me welcome a couple great guys as well, Jeff Bradshaw and Grime McCracken, who will be talking about this for the next few minutes.
Well, thank you very much. Unfortunately, Michael gets to play with planes, we get to play with tractors and combine harvesters. So not quite as exciting, but hopefully you'll find what we're doing quite interesting. Just to kind of set the scene, I'm the non-technical one, Jeff's the brilliant one.
Actually, no, let's Lewin and Theo over there.
Yeah, no, we'd. ProAgrica is a relatively new division for RBI. It's where we've rolled up all of our agricultural assets around the world, and we split up into 4 divisions. We got Media, which is Farmers Weekly, and a product called Border Eye, really good journals. We got Software Business, which is farm management systems. If you're running a farm, it allows you to measure yield and do precision agriculture and pay your workers. We have a new bit which we bought about a year ago now, isn't it?
just come up to the year anniversary. Yeah.
Yeah, called, which is originally called Adaptress, still is called Adaptress. And that one is this enterprise service bus. And then part of the reason we bought this business, or a lot of the reason we bought this business, was it's very strong in agriculture. About 80% of its business is in agriculture. It's also in financial services and in aerospace. If you've flown on British Airways, you've used their tools. You just don't know it. And the thing that was really impressive about it was that it doesn't actually care which industry it's in, and it connects up anything to anything. So we took that and we wanted to say, how do we take this and really see if we can flip that into a data and analytics business? So that was the concept, and over the last, year we've been working on that. And it's an interesting place. So again, we get cows, they get planes. That's a Highland cow, so I'm Scottish, so I chose a Highland cow. But the amount of data is amazing. You know, I'm fairly new to agriculture, so I'm still learning about it. But it's got more data than any other market I've ever seen. You know, everything is generating data. Cows are generating data. Individual cows are generating data. Sheep are generating data. We had a project in the Netherlands called Fitbit for cows. So we know where a cow is in a field. We know when a cow goes to the loo in a field. And that's important because when they go to the loo, that's them fertilizing the field, so you have to put less input in that field because they've already done the job for you. But you look at there's 570 million farms, 25 million tractors. So I think we've got more tractors than you've got planes. 50 billion chickens. You don't measure them individually because they don't last very long. It's a very transitory life, a chicken. 1 billion sheep, mostly in Wales. Given that we're coming up to Thanksgiving, I thought I'd bung in 80 million turkeys and 1.5 billion cows in the world. With 100% of them in the UK have their own passports. Only 36% of the Americans here have passports. So the cows in the UK are more well-travelled than you guys. And Big Brother, Big Data is really watching you. It really is like Animal Farm. So if you're a cow, you're a sheep, you're a chicken, if you're a fish, then you're being monitored. We will talk a little bit later about our entity models. We don't just do arable, so what's been planted in the field. We do, sheep and cows and fish. So we have our entity model is probably going to be like 4 legs, 2 legs, no legs. So really interesting places to be.
And this is just a few stats around why agriculture is important and why the data is important. So, obviously the population of the earth is growing. Arable land largely hasn't changed. We're not rustling up more farmland. In fact, we're getting less because people want to build houses, and climate change means that land that we used to grow on, we can't. So, yeah, it's kind of a scary thing, but the stat there is double the food demand by 2050. The impact that has on yields means we've got to basically move agriculture, and this is why precision agriculture is important. In the next 50 years, we've got to make more from what we have than we have in the entire history of mankind. So from back when the Neanderthals were out there trying to grow something, we're there now at this point in time. So huge amounts of data, huge amounts of stuff to help us get yield out of the field.
What our theme tune on the way up, I was thinking about it, should have been Feed the World, the Live Aid song, because in reality that's what our motto is about. We want to feed the world, more outputs with less inputs, farmers being more profitable.
So this is kind of interesting, how can data help? Because the first thing you think about, and most people grow plants at home, right? The weather kind of screws up the crop, right? Actually, it doesn't. It's not only weather. So it's things like nitrogens, hybrids. So what two seeds have I bred together? Much like cows and things, they kind of breed seeds now, crossbreed them. What was in the field beforehand, because that can kind of mess up the earth and stop me getting a yield. How well my plants are growing, again, quite important. How they're planted, and anything we put on them to stop, so for example, stopping pests or stopping weeds growing. So there's a lot of stuff you can do to manipulate and actually improve your yield, which gets kind of interesting.
So when we look at what the entire landscape, I said earlier that there's more data in this market than I've ever seen. And the really exciting thing for me as someone who loves data and analytics, is that it's really, really badly organized. So the cow in Netherlands isn't communicating to the cow in the UK in the same way. They've got a different form of mooing, I guess. You know, different farm management systems across the world. Satellites and drones and planes are all generating data. So, you know, you get satellites coming over. We can measure yield using satellites, and we're ingesting data like that in order to pour into our farm management systems. Sensors in the field, whether it's soil sensors or Fitbit for cows, all going on. Soil type has an impact, so you have to know the soil horizon around the world. Farm machinery, a tractor generates 32 megabytes of data per day, and you saw how many tractors there are. Combine harvesters are even worse. Weather data that Jeff's just mentioned, so we actually have weather data flowing into our system, and we have that at a kilometre square. So we know what the soil moisture like was at, what the dew point was, what the soil temperature was, as well as what the wind speed was and the wind direction. This is all really important if you're spraying pesticides or you're planting crops, for us to measure the impact on yield. And then we're taking data because Adaptress already works with people like Monsanto and Bayer and BASF and all these people. We've got their data flowing through our enterprise service bus. We're taking data from that and putting it into that overall feed, so we get a full view of the market. And then we get agronomists, who are the people like the people that really help farmers increase their yields. So a whole bunch of data from them and helping them. So I've been in RELX for a long time, but I'm very particular about what we do and how we do it. And in March, when we first started this project with HPCC, we had 3 fundamental questions. Was, can it scale to the volumes of agriculture? And the answer to that was fairly quickly, yes. You know, Flavio did a great sales job on me. And then the next one was, because we didn't really know, how does it fit into with an enterprise service bus? Does it fit in with an enterprise service bus? And the answer to that was really, really surprisingly well, which is how we ended up with the Strike platform. And then the third one was, it can provide real-time analytics and real-time data. And we've got R1, so it's really doing that now. And it's end-to-end real-time, so it's really quite cool.
So this is a bit about our wonderful interlock adapter. I was trying to trademark lovely adapter, but because that's what our customers refer to them as. But the whole idea is we're really, really good at bringing data in. We have a slightly different approach to some of the other solutions in the market. Back when we first put the solution together in sort of 2000, we designed it, data centers were expensive, so we designed it to be federated out with central control. So our real sweet spot is we have the magic number's 308 pre-built adapters off the shelf that someone can go. So if you have a customer that wants to pull some data out of SAP, great, we've got an adapter, we can help you. If you've got something really obscure, like one of our aviation customers has a winds feed for these volcanic ash alerts, and we pull it down and that ends up in a pilot briefing pack. So we can do some really obscure data collection things. And the notion being that it's very simple and very scalable. In terms of performance, we have customers running these at 25,000 messages a second on a single instance. So they're really, really good at scaling. But actually, there's a screenshot there from the config. So it's all drag and drop and configure your workflow, and then you deploy it and away you go. And I think that might even be an example of spraying into Thor. I'm trying to work out. So
I can't read it.
This is something we did very quickly when we first started playing with HPCC. So.
Yeah. So, this was your slide. So.
Oh, okay. Yeah, all the work, don't I? So we came up, we sat with Flavio and Arjuna and the team. They got quite excited about the interlock piece and said, wow, you guys can get data in here really quick. We also did some stuff with our colleagues at Flight Global as well. So we came up with this Strike 1. And the idea is we can actually ingest data from multiple sources. Outside of the Precision platform, we also do stuff with OCR as well. So we really can take data from any source. And one of the things you'll find with farmers, they're not very good at typing, apparently. So we have to clean that data up quite a lot. So the idea is we ingest it on the left through interlock. We spray directly into Thor where the magic happens, as we say. And that's things where really smart people like Theo sort out the entities and sort out the data and make it look good. And then basically we're pulling it back out with Roxy. Again, we can either then deliver it via an API from Roxy, or recently we have a configuration of interlock which we refer to as the Roxy proxy, because it gives us a little bit of security stuff there. And the idea is then we can pull the data out, present it in different ways. So we can either take it out and feed it into a customer's back-end system, or into our analytics, and they can do the analytics themselves. So, and again, very scalable.
So this is kind of the Strike platform as we described it. So as you can see, that on the left is kind of how traditionally you would do it in LexisNexis, or LexisNexis Risk, where you have data suppliers going into a landing zone, being pushed into Thor from Roxy out to the ESP. The MBS and MBSI is the access and entitlement systems. And then a whole bunch of APIs out to customers who are typically using Oracles or SAP or specific things in insurance market or in the healthcare market. And we already have some of those adapters in order to help with those areas. So when we looked at Strike, it was about sort of saying, actually, it's about ingest and it's about output as well. So in the brave new world of Strike, the contributor and supplier could still use the landing zone, but they can also use interlock, and there's an interlock adapter that's built right into Thor. So they can push data in real time. It's very easy to get data into it because it's just it's built to. The landing zone is cool, but we were having some challenges back in the beginning, and we decided at that point it would be easier for us to just build an interlock adapter straight into Thor and just push the data straight in.
To put that into context, when we first started with our prototype project, we had 3,000 SQL Server databases. Farm management systems largely are federated out and they run them on-premise. They don't really do the cloud too much, farmers, because it's dirty and they don't trust it. It's the witches. So the idea was we'd actually take these databases, we actually have an interlock adapter that will take the data out, effectively restore the whole database, take the data out and spray it directly into Thor. We tried the SQL approach originally. It was taking about 4 to 5 hours. And that took us, I think it was like a few months to actually get that piece working. We then kind of configured interlock, tweaked it and replaced it, and we're down to about sort of 5 or 6 minutes on the ingest of about 3,000 databases. So that's the kind of speeds and differences we're dealing with here.
So, and that methodology scales to anything. So we're working with a farm management system in France that has got about 115,000 locally deployed versions of its farm management system, no ability to create a consolidated view. So what we're going to be doing with them is, well, we're planning to do with them is to build an adapter that sits right next to their applications on the desktops, sprays the data to us, we'll push it straight into Thor, we'll create the canonical form of it, and then we can give it back to them so we can give them a clean version of their own data that they can't get to themselves. So really, really cool things. So then the second part of that, so that's on ingest. And then at the moment, we mentioned the Roxy proxy. So the Roxy proxy sits exactly where you'd expect it to be, right on top of Roxy. So you can pull data straight out of Roxy. We're now building a new version of it, which sits on top of the ESP. So you can use either, and integrates into MBS and MBSI for the LexisNexis guys.
Because for us, the security piece is important as well, because it comes down to ownership of data, right? If you're a farmer, they're kind of protective about the data when you're dealing with the companies they don't like to give information to. So if you're dealing with a big company like a Monsanto, they want like all the data. So you have to kind of convince the farmer that it's okay to share his data. No one's going to use it against him later on to charge him more, clearly. They want to help them and give them better feed, better inputs to get better outputs. So there's a whole permissioning layer there we've built around the edges as well, so we can secure data down, make it either anonymous and batch it up, or give specific feeds. So I might share my data with one manufacturer, or I might share it with my agronomist to be able to give me some better recommendations. So we can actually control it quite strictly as well with that extra layer we built into the interlock piece.
So, and the second one, the output one, the top one on top of the ESP, what that allows us to do is to say, actually, we already have a plugin for Salesforce or for SAP or for 300 and odd different ones, and we'll be building out more. So you can then, the customer or the person you're supplying the data to has to do an awful lot less work in order to be able to consume the data. So really, really happy that it's been a great relationship. Arjuna and Flavio have been good fun to work with it, and we've given them quite a lot of grief. So that then, we've taken all that and we said, I actually love the fact that the Strike, that combination of Adaptress and HPCC is key to how we can do this, because our ambitions are global. We want all of the farm management systems. We want all of the satellite data. We want all of the weather data. We want all of the tractors data. We want every cow to be subscribed into our platform. We want all of it. So we needed something at scale The initial projects we've been doing, we started in arable, so crops, and it's quite interesting new terminology I'm learning. And we're moving into dairy and beef and poultry and fish and small animal and veterinary. All of this is being done now. We built the platform in, 4 months flat?
Yeah, pretty much.
We're now scaling out. The entity models fell in love with salt. We've fallen in love with salt. There's some really cool features in HPCC. So really powerful entity models. They're very complex entity models because of the nature of what we're trying to do. But we're making good progress there. And the platform went live within 4 months. We're now scaling it from there into these different markets. This is an overview of the actual platform. Do you want to take this one? Because I've been talking.
I certainly can. I mean, obviously, on the left-hand side, we've got the ingest. And effectively, as it comes through the rest of the layers of the onion, we're cleaning the data. So we're cleaning it and pulling it together. So, for us, it's things like, what was the weather like when the guy was planting? What was the weather like at the growth stage, at growth stage 2? And some of our customers have very strict, when they're dealing with their growers, with their farmers, they have very strict protocols. So they might say, on this half of the field, you're growing a specific variety of wheat, please don't apply a second nitrogen spray. Everyone here is now thinking, what the hell is he talking about? Basically, for farmers, you'll see them spraying nitrogen. It's a way of getting extra protein in the wheat. They get paid by the amount of protein in the wheat, so they're kind of encouraged to do that. This particular customer didn't want them to have high protein wheat because it doesn't bake as nicely in the bread. So they actually pay their farmers a premium to not do that. Problem is there's no enforcement. There's no way of actually knowing, did the guy do it or not, other than they go and bake the bread and it's not as good as it should have been. So this way we actually capture all that data, we can present it back to them to say, actually, your farmer there didn't comply. You should therefore go and speak to him. So we bring the stuff in. In the middle, we have the option of either allowing our customers, as we mentioned before, to do the analytics themselves. So we can give them clean, nice, lovely permissioned data, and they go do it. When we first started, before we were acquired, we started building this platform out using lesser technology in the belief that our customers would have that. To date, none of our large customers are anywhere near having that. So we then said, hang on, we better start building some analytic capability ourselves, hence the bit at the bottom where we actually let them use our data in our data center to do the analytics themselves. And then obviously the outside is the kind of inverse where we want to feed back. So it's great getting the data from the farmer, but hey, what's in it for me? We actually want to be able to take the data from him, pull it in through the system, clean it all up so it looks nice, and the agronomists can then look at it and say, yeah, this is how you should apply data to apply the crop protection to your field. This is how you should plant your crop. If you speak to a farmer, they've been doing big data for hundreds of years. I was chatting to one recently, and he said, yeah, Jeff, big data is nothing new to me. I've got books on the shelf from all my, my grandfather, my great-grandfather, and all these guys. I know exactly what they planted, exactly what the weather was like. I just can't get at it. And it's a big challenge for those guys. So now we're actually enabling them to do the magic and get to that stuff.
So what does it deliver? So we're trying to build global insight to really help farmers, help manufacturers, help agronomists, help everyone in the market, so float all the boats. We're independent, we sit in the middle, so we don't have a vested interest as a manufacturer. We're not trying to sell anything to the farmers. This visualization on the left, so the top one is actually a soil horizon. Top right, I cannot remember what that one is, but
temperature planting.
Is it temperature graph?
I'll see that.
The middle ones are weather. The bottom one's actually really interesting. That's when fertilizer and herbicides have been applied in the growing season. So you can see when they're doing that, and we're actually using salt and thaw to assess. There's certain you can't apply or you shouldn't apply certain chemicals at certain points in the season. And because farmers are a bit inaccurate about typing stuff in, they might misspell the chemical that they've applied. We can use when it's supposed to be applied to, I think you saw earlier about, seeing the bits that are the outliers to get more confident that the data we're putting in, the canonical version of the data that we're putting in is the right one. So really impressive there. The whole thing, you guys know this, it's agile, it's scalable, it's resilient and secure. That's really important for our customers, because our customers are going to be large manufacturers. We need to put that, because it's so disorganized and there's so much data, we need to be able to create that canonical version of it and keep every version of it, because we're working with farm management systems, we're feeding that back to them to give them clean data. We're giving services to those farm management systems to give to their farmers, to really enhance the farmer experience, to allow the farmer to increase his yield and take more control. We're supplying data to agronomy firms to help them get a better insight into the entire market and all of the options in that. There's a good example of a manufacturer who we have a very good relationship with, and they'd done 70 field trials of a specific chemical. They were saying that they were claiming in the market that chemical was generally there was like 30% uplift in tonnage or yield.
If you applied at a certain dose rate.
If you applied at a certain dosage rate. But they'd done it on 70 field trials. They couldn't tell us what the weather was when it was planted, what time of day when it was planted, what the soil type was. All they could tell us was what the variety was, what the yield was, and when the pesticide was applied. When we looked at a much bigger sample, we had the interesting experience of having to go back to them and say, actually, that's not accurate. Your competitor's actually a better product at the rate you're advising people to apply it. But if you advise them to apply it at a slightly higher rate, then it actually reverses and it becomes a valid claim.
Exactly. And this is an interesting thing as well, because obviously it's not just about giving the farmer a recipe and saying, did he do it, right? It's like your doctor. You injure yourself, they give you something to make you feel better. Do you take it? They've got no way of knowing. You just either die or get better, right? Same with farmers. They either kind of follow the guides, and they don't really know until the end of the season. You know, did it work? Or did you do what I told you? Well, kind of. So now we can actually circle back and say to the agronomy guys, well, actually, he followed your instructions, and he got the yield you told him. Or farmers, and this is where we also, in this particular case study, we found out where farmers are quite unreliable, because the group of farmers that got the yield that was advertised actually doubled the dose. So they'd applied a lot more, which actually makes it not really cost effective. So I don't know why. I think they must have had broken machinery or something. I don't quite know why they applied it at such a high dose. But the good thing is we have all the data. We can go back and slice and dice it in different ways to manufacturers. They can then refine their recommendations. And over time, it's quite interesting, the machine learning stuff that's coming down the line, because for us to actually refine the rules and refine the recipes that the agronomy guys are using, it's going to be a tacit benefit to this platform as we release it and get more and more data in from more and more territories. So there's a whole load more to come on the machine learning side of things. And it is actually quite an exciting space. So as you can tell, I like to eat as well. Yeah. So it's kind of important to me in the next 50 years.
Yeah, both of us. Both of us. Yeah, we're not the lightweight team, are we? But the key thing is like a massively exciting area, vast amounts of data to play with. The Strike platform we're very excited about. I know that the LexisNexis guys are very excited about. It's there, it works, it really makes life in LexisNexis world, HPCC world, really cool. There's stickers out there apparently with Strike on it, and happy to answer questions later. Absolutely. When you find us in a bar. Because we're usually
and if anyone's really kind of overly excited, if you'd like a demo, I like to run by the seat of my pants. They wouldn't let me demo because we didn't have enough time. So if anyone wants to see a demo of some Strike stuff going on and some of the adapters, come and find us. I'm around. Lewin's shyly hiding over there. Don't be coy. He can also help on that sort of stuff. But if you want to see some stuff in action, come see us. Come ask us questions. We're kind of friendly, especially with beer. So yeah, thank you.
Good job. Okay, very good. And now, I have an important announcement from these guys. They didn't want to say it, but this is an NDA because a new product is called Muit. It's like tweet, but for cows. So you can moo instead of... Well, we have our break now. It's going to be a short break, though. So go grab coffee, again, buy your break. But come back in 5 minutes if you can. We have some community awards that we want to give quickly before we start the next session. So 5 minutes, buy your break, coffee, and come back. Thank you.